Welcome to the second part of the discussion on the adjustment of closed traverse. So if you missed the first part of this discussion, I provided you the link in the description below. Just click the link. And in this video, we will apply what we have learned in the first part, or we will try to solve an example. Now we have here our first example. Now from the given data of closed traverse, we have lines AB, BC, CD, and DA. So this is a four-sided traverse. Now line AB has a distance of 368.76 meter. BC has a distance of 645.38. CD has 465.86, and DA has a 593 meter distance. Now the bearing of these lines are, for AB we have north 15 degrees 18 minutes east, BC has south 85 degrees 46 minutes east, CD is south 18 degrees 30 minutes west, and DA has a bearing of north 77 degrees 35 minutes west. And now let's balance this closed traverse using the first method. And now let's use compass rule first. So our goal here is to adjust this traverse, but again, the first thing we do here, or the first thing we should do here, is to compute for error of closure. Okay, if we found out that it has an error of closure, then that's the time that we apply transit rule or compass rule. But if we found out that there is no error of closures, then there's no need for adjustment. Again, we have two different methods. We have compass rule and transit rule. But in this video, let's begin with compass rule. So let's use compass rule first. To compute for error of closure, we need to compute first the latitudes for every lines, and as well as its departure. Now let's start from AB, from line AB. To compute for latitude, again, so I have derived the formula in the first part of this discussion, and we know that the latitude, or the distance along the latitude, is equal to the distance of the traverse times the cosine of the bearing angle. Okay, so let's compute for the latitude distance. So we have the distance of the traverse for AB, we have 368.76. So this one here. Then we have its bearing, which is north 15 degrees 18 minutes east. So we have cosine of 15 degrees 18 minutes. So we have the value of our latitude for AB. We have 355.69 meters. So for latitude, we have here 355.69. Now take note, we have our direction, which is north. Now the sign of our latitude, again, depends on whether it is on the north direction or in the south direction. But in this case, AB here, the direction of AB here is along the north, so therefore that is positive. So we have positive latitude. So we are done with its latitude, then we can now compute the value of its departure. Now departure, again, this is equal to the distance times sine of beta, or the sine of the bearing angle. So we have departure, which is equal to the distance of AB, we have 368.76 times sine, the angle is still the same, 15 degrees 18 minutes. So the value of our departure here is equal to 97.306 meter. So we have here the departure is 97.306. Now take note, the direction of our line AB is northeast, and we have direction here, the direction of our traverse along the east side. Okay, so therefore our departure here is positive. If it is west, then that is a negative departure. Now we are done with AB. Now let's move to BC. Now to compute for latitude along BC, the formula is still the same. The latitude distance is equal to the distance, which is 645.38 cosine of the angle 85 degrees 46 minutes. So we have here the latitude of BC, which is equal to 47.641 meters. So we have the latitude is 47.641. Now take note, we have south direction for BC, then therefore our latitude here is negative. For the departure of the traverse BC, we have departure is equal to 645.38 sine of the angle or the bearing angle, which is 85 degrees 46 minutes. So we have the departure here, which is equal to 643.619 meters. So we have the departure, which is 643.619. And we know that we have our traverse direction along the east side. So therefore, that is positive. So using your calculator, you can directly compute for the value of the latitude and departure without going through this formula or this computation. So this is important calculator technique. So you can just go to the rec. Okay, if you have this type of calculator, go to the rec option in the minus button. Okay, so you just shift, then this negative or minus button here. Then you have now the rec. Then you encode or you write the distance. So we have 368.76. Then we have comma, shift, then this one that is closed parenthesis. So we have comma. Then the angle, we have 15 degrees 18 minutes. Okay, then close. So you have to press the equal button, then you have here. Now the problem is, if you want to use calculator now in solving the value for latitude and departure, you need to be careful on which latitude and departure here you want to choose. Now we know that in reality, the latitude is supposed to be the y-axis, or it is the y variable here. But in calculator, it is the opposite variable. Now take note, the latitude here is given as the x variable. We have 355.69. Okay, and the departure here in the calculator is given as the y variable, but in reality, departure here is supposed to be the x variable. Okay, you have to be careful on which to choose, on which value to choose for the latitude and departure. So again, you can go directly using your calculator or by using this formula here. Okay, but to make it simpler and to make it shorter, so we use calculator instead. Now for line BC, let's try to check it using your calculator. So we have shift, then rectangle, the negative sign, then you have 645.38, then comma, then 85 degrees, that is the bearing of BC, 85 degrees 46 minutes. So you have your x value here, which is the latitude, and we have here negative 47.641. Again, you have to indicate the sign, okay, since the calculator will show you the positive value. Then for the departure, we have 643.619. That is for the departure, and we have the y variable. Now let's proceed to traverse CD. We have shift, negative or minus sign. We have the distance 467.86, comma. Then we have the angle, the bearing angle 18 degrees 30 minutes. So we have the value of our latitude here, which is 443.683. That's again, it's in terms of meters. Departure is also in terms of meter. Now take note, the latitude here, or our line here, is along the direction southeast. Okay, so we have south as the direction for the latitude, therefore this one is negative. Now for the departure, we have the departure is the y variable here, which is 148.454, And we know that the direction is along the west direction, so therefore this one is negative as well. Okay, now for dA, so we can use the calculator again. So shift the minus sign, 593, 77 degrees 35 minutes. So this is the bearing of our line dA. The value of our latitude here is 127.507, and we have north direction for dA, so that means it's positive. For the departure, we have 579.13, that's the y variable. Now take note, we have a west direction. Okay, so therefore this one is negative. So we have now computed the latitude and departure for each traverse. Now again, we know how to compute using either this formula here or by using your calculator. Okay, now let's check for error. All you need to do here is to sum up the latitude and sum up the departure. So you have 355.69 plus negative 47.641 plus negative 443.683 plus 127.507. So the result would be negative 8.127 meters. For the departure, you just add all this value, but you need to include the sign. Okay? We have 13.341 meter. So this is the error of closure on the departure of that traverse. Now the negative error here, that means that we are lacking of this value in our traverse. So kulang. But we have departure here, we have 13 positive value. That means that we have excess line. Okay, so may sobra, which is 13.341. Now, later on, in the latitude side, we add all the corrections to suffice the error of closure. But in the departure side, since this one is the excess, so therefore, we subtract all the corrections. Kasi since sobra ang 13.341. Okay, so we now compute the corrections for each traverse using compass rule. Now, in my previous video, I presented to you the formula that we need to follow in order to compute the correction along the latitude and along the departure using compass rule. Now, for the correction on the latitude, this is just the total closure on the latitude times the distance of the traverse over the total distance. So, to compute for the total distance, we need to sum up, or you need to compute for the perimeters of our traverse. So, we have to sum up these distances here. So, we have 368.76 plus 645.38 plus 467.86 plus 593 meters. Okay, so our total distance is 2,075 meters. So let's begin with the line AB. Okay, so we compute for the correction of the latitude of AB. So we have here the closure of the total closure along the latitude. So we disregard the sign. We have 8.127. So do not include the sign. Times the distance of AB, which is 368.76 over the total distance or the perimeter, which is 2,075. This gives us the correction of the latitude on traverse AB, which is 1.444 meters. Okay? Now, for the correction of the latitude BC, so we will be following this again, this equation again. So we have the error of closure on the latitude, we have 8.127 times the distance, we have 645.38 divided by 2,075. This gives us 2.528 meters. Now, for the latitude of the traverse CD, we have here 8.127 times the distance 467.86 0.86 divided by 2075. This gives us the value of the correction of the latitude CD, 1.832 meters. Now for the correction along the latitude DA, of the latitude of our traverse DA, we have here same formula, 8.127 times the distance 593 divided by 2075. We have the value 2.323 meters. So these are the corrections of the latitude of our every lines in the closed traverse. Okay, so how are we going to compute for the corrected latitude? So this is now the transformed or the corrected value of our latitude. Now take note again, since we have negative here, that means kulang or lacking. We have 8.127 deficit in the length, okay, of our traverse. So that means we add all these corrections. Let's begin with AB. So we have the length is 355.69. This is the departure, plus the correction of AB, which is 1.444 meters. So we have 1.444. This gives us the corrected value, 357.134 meters. Okay, so our corrected latitude of our line AB is 357.134. This is in meters, still in meters. Then for BC, the latitude is negative 47.641. Then again, we add the correction, since again we are lacking of length. So the error of BC is 2.528. 2.528. Don't forget to include the sign of our latitude value. We have negative, okay? So that means we have negative 45.113 meters. So we have negative 45.113. This one again is in meters. For CD, we have the value of our latitude here, which is negative 443.683. Then we sum up the corrections, which is 1.832, 1.832. The result is negative 441.851 meters. So we have negative 441.851 meters. Then for DA, the last one, we have here the value of the latitude, which is 127.507 plus the error, which is 2.323. This gives us 129.83 meters. So we have 129.83 meters. And that is positive. Now you can check if you have correct answer if the error, if we sum up the corrected latitude here, would be equal to 0. So if they have a sum of 0, that means we have correct answer. So let's try to check. So we have 357.134 minus 45.113 minus 441.851 plus 129.83, and this equals to 0. So the error of closure on the latitude of our traverse is now 0, or it becomes 0 after we adjust the latitude distances. Okay, now let's move to the departure. So we compute for the corrected departure. To compute for the corrected departure, we just use this formula which I presented on the first part of this discussion. We have correction along the departure is equal to the total error of closure of the departure times the distance over the total distance of that traverse. So let's begin with AB. The error of closure AB is equal to the closure of the departure, which is this one, 13.341 times the distance of AB. We have 368.76 over that perimeter, which is 2075. So we have here the value of the correction, which is 2.371 meters. Okay? Now for the departure correction of the departure of the traverse BC, we have the distance, or we have the correction, which is 13.341 times the distance of BC, which is 645.38 divided by 2075. This gives us 4.149 meters. Now for the departure of CD, we have 13.341 times the distance 467.86 divided by the perimeter 2075. This is equal to 3.008 meters. Now for the departure of DA, we have 13.341 times the distance of DA 593 over 2075. This gives us the value 3.813 meters. So this is now the corrections of the departure. And now let's compute for the corrected departure. Okay. Now again, take note, the error of closure in the departure is positive. So therefore, there is an excess of 13.341 meter or measurement. Okay, so in order to compute for the corrected departure, we subtract this correction, since again we have an excess measurement in the departure. Okay, so we have AB. For AB, we have the departure 97.306, this value here, then minus the error, which is 2.371, and this gives us 94.935 meters. Okay? Now for BC, for line BC, we have 643.619 minus the error BC, which is this one, 4.149, and this gives us 639.47 meters. For CD, we have the value of the departure, which is negative 148.454 minus 3.008, the correction of line CD, this one. So this would give us negative 151.462 meters. And lastly, we have DA, which is negative 579.13 minus the correction of DA here, 3.813, which is equal to negative 582.943 meters. So these are the corrected departures for every lines respectively. So now, if you want to check if your computation of this departure is correct, then you just add all this value and this should be equal to 0. Okay? So let's try to check. And this equals to 0. Okay, so I add all this value departure, so that means we eliminated the error of closure. So we can now compute for the corrected distance by just using Pythagorean theorem. If we have this one, if we have a value of latitude, which is we know per vertical, and we have the value of departure, which we know that's the horizontal. This one is the departure. So our distance is this line here, the connection between latitude and departure. So this is the distance. So how are you going to compute for the distance? By Pythagorean theorem, we have distance is equal to the square root of the departure squared plus the latitude squared. Okay, so for line or for distance AB, we have the square root of the latitude 357.134 squared plus 94.935 squared. This would give us the distance 369.537 meters. Now for BC, using the same theorem, Pythagorean theorem, we have the latitude or the departure, which is we have negative 45.113 squared plus 639.47 squared. The distance is equal to 641.059 meters. We have here 641.059. Similarly, we can compute the value of the corrected distance for CD and DA. So we have here 467.089 for line CD and 597.226 in the line DA. As what you can see, for DA, there is an increase from 593, it became 597.226. Okay? So, then we compute for the corrected bearing. Now, our bearing here has been changed since we have now different value for latitude and departure. Okay? So, how are you going to compute for bearing? Now, again, the angle or the bearing angle here is at this side. Okay, this angle beta, which is always refers from latitude, okay, or from the vertical axis. So to compute for angle beta, we can just actually use tangent. Tangent beta is equal to opposite over adjacent, which is the latitude. Okay, tangent theta is equal to opposite over adjacent or departure over the latitude. So therefore, we can say that beta here is equal to arc tangent of departure over the latitude. Okay, so let's compute now the bearing. So we have the bearing of line AB is equal to the arc tangent of the departure. We use the corrected departure here, which is 94.935. This one over the corrected latitude, which is this one, 357.134. So this will give us 14 degrees 53 minutes 10.91 seconds. Okay, so we have 14 degrees 53 minutes and 10.91 seconds. Now take note, what should be the direction? Now look at the sign of our latitude and departure. Now take note, our latitude, our corrected latitude here is positive. This one. That means the direction of our latitude is along the north axis, or it is a north latitude, since again that's positive. So we have north. Now for our departure, still this one is positive, so therefore this is an east departure. So we have northeast. Okay? For bearing of our line BC, we have arc tangent of the departure. The departure or the corrected departure here is 639.47 meters. See this one divided by 45.113. Now take note, you must disregard the sign. Okay, you get the absolute value if you want to compute for the bearing. So we have here the bearing, which is equal to 85 degrees 57 minutes 52.61 seconds. Okay, so we have, now take note, our latitude here is negative for BC, therefore we have the direction along the south latitude. For departure, we have positive departure, that means we have east departure. Okay, that's still southeast. So using the same formula, we have the value of bearing of angle CD, which is arc tangent of 151.462 over the latitude, which is 441.851. This will give us the bearing or the angle, which is 18 degrees 55 minutes 16.28 seconds. Now, looking at the latitude, we have negative latitude for CD. That means we have south. And we have negative departure. That means we have west. Okay, so therefore we have southwest direction for CD. Now, for DA we have the angle, which is 77 degrees 26 minutes 39.49 seconds. Now, looking at the latitude, the corrected latitude of DA is positive, so therefore we have direction north, and the departure is negative, so therefore this one is west. Now, this is now the newly computed bearing due to our adjustment using compass rule. Okay? Now, let's try to use other method. We have a transit rule. Okay, in transit rule, you expect that we come up with different answer. Okay, now in my next video or in the part 3 of this discussion, we will try to solve the same problem using transit rule. I would provide you the link of the part 3 in the description. Thank you guys for listening, and please don't forget to like this video and subscribe to my channel. Have a good day and God bless.